Hi, camera.
Hi, everybody that's missing from Jake. Okay, so welcome back. Hope you're all fine and happy to see everybody again. Yeah. The camera is for e-learning. I'm going to put this on haiku, so if you're absent, if there's a mess tomorrow and you're absent, you can go on haiku and you'll see the next thing that's happening. So, multiplying and dividing rational expressions. We have been dealing with x squared this and 5x that for a long, long time. There is a big difference between a basic multiplying problem and a basic adding and subtracting problem when you're trying to cancel things. We know that if you have something like 6 times 2 over 3 times 4, if it's all just multiply, 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 we know the order of operations would be let's get the numerator and let's get the denominator and reduce that as 1. But if it's all multiplying, you can cancel little bits as you go. And what you end up with is 2 over 2, which is still 1. And you could keep canceling even, and you get 1 over 1, which is still 1. So if the basic thing is a multiplying problem, you can cancel at will. But be sure and cancel, this is multiplying, that's multiplying, this is multiplying, this is multiplying. Do not ever reach inside. Don't reach inside of a little bracket and try to cancel like that x with that x. That's bad math. But if you can get this whole bracket to cancel with this whole bracket, since these are multiplying, with multiplying you can cancel at will. Okay? So what this one will actually look like is 2x over x squared minus 1. This is a difference of squares, and we will see in later problems where we'll have to factor that to see if it could cancel with something up here again. But if you factored that, what would it look like? X plus 1, x minus 1. Remember, it's a subtracting perfect squares, x plus 1x. Is there any way one of those might cancel with 2x? No. So you can see that in advance sometimes. If you're really good at this, you can see that ahead of time and say, that's good enough. All this will make is 2 brackets, and neither of those brackets is ever going to cancel with that top. Okay, so that's how you would proceed here. And this would be a perfectly wonderful answer. And again, don't try to cancel anymore. Same thing here. We would like to cancel x squared with x squared and x with x and 4 with 6. But this is basically an adding and subtracting problem. And when that's the case, you cannot cancel little pieces.
Would you long divide?
You could long divide, but we're going to factor and cancel. So, for example, we all know the order of operations would be, let's get this top, let's get the bottom, and what's the answer? 2. But if it's an adding and subtracting, I can no longer cancel little bits like I did when it was multiplying. Let's do cancel little bits, and we'll see that we end up with a rubbish answer. So does 3 divide 3 once, and 2 goes into 6 3 times, and what did we end up with? 3 plus 1 is 4 plus 1 is 5. 5 over 1 plus 1 is 2. Is 5 over 2 the real answer? No, the real answer was 2, and we knew that 100% sure thing. So when it's adding and subtracting between those, you can't just cancel little pieces because you end up with a terrible answer. So what do you do? Dan suggested long dividing, but we're going to factor instead. Remember factoring? How does that top one factor? What can multiply and make negative 12 and add and make 4?
6 and negative 2.
1 times 12, 2 times 6, 3 times 4. Any of those could add and make 4? How do we get plus 4? Negative 2 plus 6. So x minus 2, x plus 6. Good. Always check. Multiply, negative 12, perfect. Add, plus 4, nice. How about the bottom? What can multiply and make 6? And add and make 1. How can we do? Who can add and make 1?
Negative 2 and 3.
Good. So, minus 2 plus 3. X minus 2x plus 3. And then what do we notice? We have turned an adding problem into a multiplying problem. And what did we say when it's all multiplying, multiplying? We can cancel nicely. And what can we cancel?
That one.
Yeah, that one. And what's left is x plus 6 over x plus 3. And that's the best we can do, because, again, this is now an adding problem, plus plus, not a multiplying problem. So don't start trying to cancel, cancel, or cancel, cancel. This is as far as you can go. So, in this one, factor this, see what big brackets can cancel. What about the guys in the front? Are they multiplying each other so we can cancel those little bits? Are those multiplying, 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 multiplying? Yeah, so you can cancel the 4 and the 12 and the x with the x squared, and then factor that and get the brackets all out and cancel brackets. So you can cancel these little bits, because that's times, 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 and times, times, times. So those can cancel. And then these brackets, once you factor them, so try that.
So we could leave the brackets alone and just...
You cannot leave the brackets alone. You need to factor those and see if little brackets can cancel each
But
other.
can we like cancel out somehow 4x to the third and 12x?
Yes, absolutely. That's what I was saying about all of these. These are multiply, multiply, multiply. So when they're all multiplying, you can cancel little bits.
But, and then we can just leave the brackets for now and then cancel those out. So,
Yeah, you could leave the brackets for now, but after you cancel the little bits, then you still have the brackets to factor in and work on. Up to you. Yeah.
3x over 2x.
So we're just gonna do
One flew over the Wait, we're being
it's better. But there would be one. Wait, then who are the yellow shirts that like against that?
There's no yellow
Wait, why do you? Not even gonna bother. No one move. I mean, like a lot of people it'd be really funny. Imagine oh, that'd be really bad. That's really stupid. Didn't that
I don't understand why the government's letting like a protest block the entire city. That would not
do you cancel first?
They're just letting them block the entire city.
What are you gonna do? Yeah, don't block the entire city.
Yes. They're letting them.
Well, what do you think they're gonna do? Like, no, you can't do it, or they're like being tied or
They're letting them block the entire city.
what can they do? It's like 5 seconds.
If there's no
I don't know. No, you don't understand. Letting them, like, okay, yeah, sure, fine.
So you don't have to touch everyone?
No, that's not what I'm.
They can't stop
You're being all dramatic about this. You're going to another law. Talking about the fact that they're just letting them. They're just letting them walk the entire city.
Can I have my glass?
Wait, guys, I
don't think that's a hit a wall. I think it's my I don't know what to do.
Okay, so as usual, I only got about halfway around the room. But
I got stuck.
you got stuck? You should have raised your hand earlier.
I hit like I hit you like in the middle and I just like stopped.
don't like factoring.
Okay, what can multiply and make 8?
Oh, you factor.
And add and make -7. Can these add and make -7?
Both did the same.
Yes. X plus 1 and x minus 8. What about these guys? That's a difference of perfect squares. That's x squared and 8 squared. So it's x plus 8 and x minus 8. So now we can cancel that whole bracket with itself there. Since these are all multiplying, what did we say about multiplying, guys? They can cancel with each other. So 4 goes into 4 once, 4 goes into 12 3 times. Can that x cancel one of those x's?
Yeah.
Definitely. So that x will go completely, and if you cancel one of those x's, you're left with x squared. So what's left is x squared with x plus 1 on the top, and 3 with x plus 8 on the bottom.
Oh,
Yeah, so that I
we factored across the 4x and then the bottom here.
cross first, so we did whoever. That was really hard.
Yeah.
No, I had the x squared.
So who got this? I saw my hand. Any questions about what happened there?
Oh, sorry. Calm down.
One more.
Do you see this? This is not, that's not nice. Dan, stop.
Jen doesn't like my
I had to
sticker either.
check.
It's funny.
Oh.
Pandemonium with pandas. Perfect. This is for kids. It's our class.
Right.
Wait, I still want to do
Oh,
the.
it's
I still want to do it right. Wait, this is another question. Wait, all of this one listers. Yes.
So you people at home should be working on this same problem right now.
Wait, is this live? Like,
It's
No.
on, but no, they're gonna have to.
it was like a
No,
bit.
but
I know it could have been. What?
There's a live one out of classes.
There are live ones in other classes, but I wasn't sure how we would schedule it so they would know when I was live and when who was live. I know
What if they have a
they could be live.
schedule?
I know. Everybody that's in our class right now should be live, should be like live now. But I'm not sure what kind of situation everybody at home is in right now either.
Maybe they're still sleeping.
This way,
I got it for it.
so this way this will be on haiku and they can
They can probably hear it.
see it anytime. Yeah, they can hear you guys blabbing away at them.
Hey y'all. What? No, I'm still thinking.
Don't die, it'll probably hurt. I
I
haven't tried it though.
Write down all the things that can multiply and make 12. Basic kinetic, like I always do, and then jump right out.
Whenever you say like anything in second square, like
Oh, that's such a cute tin. That's really good.
don't think it's great. I used to do it.
wait,
Wait, you used so much. How could you like shitting?
How did you have 4 up here?
Child porn. I remember that.
Okay, here we go.
I got it right away.
How do you know? I haven't told you if you're right or wrong yet. So these are both 12. What can multiply and make 12? And add and make plus 1. These guys can
3
make
and 4.
good. -3 and plus 4. Always check. Multiply -12, add plus 1. Yay. Now, what can multiply and make 12 and add and make 7? How can we get 7 out of these guys?
You can.
Same ones, right? Can those make 7 if it's plus plus? And then x plus 4, x plus 4. X plus 3, x minus 3? No, they have to be exactly the same before you can cancel them. And those are, so don't touch those. You're left with x minus 3 and x plus 3, and that's good. Stop there.
I
a very tricky thing that you'll find is x minus 3 and 3 minus x. They are exactly the same, only backwards. Do they cancel and make 1?
No.
Aren't they the same?
Because you have negative 3 and positive 3, and then you have negative x and positive x.
Yeah, they are not exactly the same, are they? As
They're
Dan
exactly
just-
the opposite.
They're just exactly the opposite. So, what does happen though is I can factor a negative out of either one of these. This is easier to factor a negative out of. If I factor a negative out of these, what's left? A negative times a what makes a positive.
3 plus x.
What does this have to be? A plus 3 or minus 3 to be this again?
It has to be negative.
What's negative 3 times negative 1?
Positive 3.
Positive. And what does this have to be so that we keep a minus x?
Positive x.
A positive x.
Why did you do that though?
We'll see why I did that though.
There's still a negative 3.
Let's check it. What's a negative times a negative? A positive. And a negative times a positive is negative. So this is exactly the same as it was before. And why do you do that? Because you'll see, if I rearrange these and put the positive x first and the minus 3 last, what do you notice now?
So it's exactly this.
Now these two are exactly the same. I can cancel them. And what's left? 1 over, what's a minus 1 times 1? Which is? Negative 1. This will happen every time you get the guys exactly the same, only backwards. They will always reduce to negative 1. So if I give you a minus b over b minus a,
It's negative 1.
it will be negative 1. But they have to both be exactly backwards, like Dan said. This is a plus a, this is a minus a. This is a minus b, this is a plus b. When they're exactly backwards, but they look the same, only exactly backwards, then you'll get a minus 1. Which means that this is a very messy one here. This is not 2 brackets. You can't factor this into bracket, 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 bracket. What you can do is factor a common thing out of the top. Nadia, what's in common in those two?
The z squared.
Z squared. If I factor z squared out of the top, what's left? If I take z squared out of these, I'm left with
W.
w. If I take z squared out of this, what do I have to write? If you take everything out, you put a
Y.
put a 1. What's z squared times 1?
Z squared.
It's still
Oh,
z
that's
squared.
right, yes. Of course.
What if I put a 0 there? Anything times 0 would be 0. So what's in common here? Z cubed. What if I take a z cubed out of this one? If you take everything out, what do you always write? Good, Olivia, 1. And this is a minus again. What if I take z squared out of this guy? What's left? W. And these can reduce with each other. What will happen? These two z's will all cancel with 2 of these z's. What will happen if you cancel 2 of these z's?
Why is it?
There's one z.
There will be 1 z left on the bottom. So those 2 z's will cancel 2 of those z's, but there's 3 of them, so 1 z will be left. Dan.
Why is it negative W and not negative 1?
Because when we took the z squareds out here, there was a w left. So you write it. The only time you put a 1 is when you're taking everything out. We took z squared out. When you take everything out,
So you took a negative z squared out, or
I
you
took
took a z squared out?
I took z squared out.
But then you have a negative?
Have
Oh, wait, yeah, okay.
Yeah, because what's z squared times 1? Z squared. And what about these two brackets, ladies and gentlemen? W minus 1 and 1 minus w.
So it's negative 1.
It's minus 1. There's that minus 1. W minus 1 and 1 minus w. They cancel, leaving a negative 1. So what do you write for a final answer? What's on the top? Negative 1.
What do you do with that z though?
Is it negative 1 on the bottom?
No, the z's on the bottom.
Oh, so you can't put anything else?
There's nothing on the bottom left. You can put a 1 on the bottom. You mean when I cancel this and this?
Well, when do you know where to put the negative 1 or on the bottom or on the
Put it outside on the, yeah. I was going to talk about that in a minute. Let's leave this minus sign for a second. I put it right there. But what is he saying is, how do you know where to put the minus 1 and where to put the plus 1? All you do is, you know that these make minus 1. It doesn't matter whether you put the minus 1 here and the plus
So
1
it's
there.
just z minus 1.
Because in the end, you're going to decide if it's a negative or a positive final answer. So, back, what's on the top? Is there just a 1 left on the top? 1 times 1 is 1. And what's left on the bottom? Z times 1, which is z. And what about the minus sign? Should I put it on the top or the bottom? Or should I just say, what is a positive and a negative when you put them together? What's a positive and a negative always make?
Negative.
Negative, so just put the negative out in front. So that negative 1 will just stay out in front of the whole thing.
Wait, why are you saying that both of them they just cancel out to 1?
Yes.
But
Remember these guys that are exactly backwards? Cancel minus 1. So cancel, cancel. Remember that there's a negative 1 in there.
Okay.
So you get this times this, which is a minus 1, over this times z times 1 is this z. So there's the answer, minus 1 over z. Try that one. Okay, what's in common here? X, take an X out of there. Y, take an X out of there. What's in common here? X squared. What's left? 3 minus Y. Will that X cancel one of these, leaving one X on the bottom? And those will cancel, leaving minus 1. What are we going to write? What's left on the top? 1. What's left on the bottom? X. What about the minus? Just stick it in front. We got minus 1 over X. Okay. If you do put the minus on the top or the minus on the bottom, it's still okay. Okay. Are these all multiplying? So we can cancel little bits, 1, 1, 1, 1, 1, yeah. Since it's all multiplying, you just start canceling stuff. Okay, there's 5 on the bottom, cancel 15 3 times. What divides these? 4 into 4 once, 4 into 16 4 times. There's 1 B there, that will cancel one of these B's, it's just 1 left. That 1A will cancel one of these A's, but the A squared. So 1 times 1 times 3 times B. And 1 times 1 times 4 times A squared. Always look at your answer to see if there's some little thing you forgot to cancel. Who got that one?
It was bad.
Oh, then you're
Dividing.
Right.
Yeah, and then you change the 5AB to...
Wait, you flip
It
the
opens
second
yeah, you
one.
flip.
Yep. Everybody remember when you divide fractions, you leave the first one alone and flip the second one, and then start canceling. When you're dividing two fractions, you do the first one exactly the same. That's right. All cancel.
I couldn't tell which one was canceled and which ones were just like, so I just scribbled them out because I didn't want them to tell. It's really small.
There's two. I wrote the question down. Oh my goodness. Okay, let's do this. Wait, I wrote the question down.
Way to go, Dan.
That's why there would be
Still seconds left.
I need to know just already dating.
Instead of comfort, what's comfortable? It's comfortable.
Actually, I've been up since 4 a.m. I feel like I've been awake forever.
Wait, why?
I'm jet lagged. I got back last night at 5.
Because, like, all the teachers said, oh no, they're following schedule. Oh, she comes up and holds up at 4.
Yeah, I have to know that.
Yeah, I don't know that. Like, sort of like, I can understand. Is pendulum, what is pendulum? Is like that pendulum? Like who's that?
Have you ever had
How is
oh, you messed up at the start? And then
okay. If you can listen for a minute. So when you're dividing fractions, you leave the first one alone and turn the second one upside down and turns it into a multiplying problem.
3x squared.
And what can cancel? 2 can cancel 4 twice. 5 goes into 15 3 times. That 1y can cancel one of those y's. That leaves 1y left. X and x squared. That x will go. Only 1x left. That 1a will go. If you cancel one of those a's, you still have 2. B cubed, B cubed. Those go completely. 2x. 3a squared y. Who got that? Marsha, yay.
Yeah, I got it. I got it. I got it.
Okay. I am going to do this one really to save a little bit of time here. But you're going to tell me what the master idea is. What's the big plan?
Make it.
Turbo?
Factor it.
Factor these guys? Factor all of it, right? Okay. So what would that be? X plus 4, x minus 2.
I would take your pennies.
Here's a little bit tricky bit. What about that? Leave it?
Factor out 3. No, you can't.
You can.
What would you? Oh, the 3, of course.
Good. The 3.
No one's stopping you.
And
Salt?
anything can cancel. Not very much. X minus 2 with x minus 2. X plus 1 with x plus 1. What's left is 3 x plus 4 over x plus 3.
I could have done that in a cart.
You could have done that in half the time it took me.
Oh yes, of course, of course.
So, do this one.
Okay, come on, let's do this. No fun and games. Just work. We're gonna.
Nobody's listening.
Of course, everybody's listening.
Sorry, what did you say?
Kids at home. You better be doing this right now, just like always. For effects, I write down the full question first.
So do I.
You know I knew you knew.
I will I'll let everybody vote except you.
I guess I would be angry.
I'll be the
Okay, let me call me up when you're done, okay?
It's like 20 years since like aliens went
She's like, it's my person would have voted anyway.
You go into office,
I'm not allowed.
You almost made me for not voting.
Did we say hashtag?
I'm trying to insult you.
Yes, stop. Wait, but I actually think you could be. Why am I such a bad? But I think you'd be one of those to work with? Oh my gosh. People would be like,
That's not true.
yes, you would.
cut ties with that country.
You were so intimidating.
But
I'm like,
not-
no, we're doing this. Don't even try and bother.
Like,
But that's a powerful
question, I'll try to
That's a
go.
good leader. Like,
see.
Obama's such a wuss. Seriously. Oh,
It's recording.
Nice job.
We're gonna win.
It's like, let's say I come to the Prime Minister of Israel, like, in a few years, and then this footage of this camera right here.
Those people like really intimidated at the Israel or like the North Koreans. They're so like that's cool. It's recorded again too.
Everybody
World peace. Yeah.
World peace starts with
Assassination is never the murder does not solve anything. You know what does? We need freedom, equality.
Yeah, but you'll achieve
Okay.
that by murdering the people.
Dan. So flip it upside down, leave the first one alone, multiply, cancel, a minus 3, a minus 3, a plus 3, a plus 3. What's left is a plus 2 on the top, a plus 4 on the bottom.
1.5. 2.5.
Should I cancel the 2 and the 4? Should I start canceling little bits?
No.
No. If there's for sure.
Rubbish answers if you do.
Yes.
Rubbish answers.
If there's little addings and subtractings, separating them, do not try to cancel little pieces one at a time.
Remember, folks. Don't cancel. What is this?
When you have a triple stack fraction in 2 minutes flat, what you do is you put this and is this a dividing? So it's a over 5 divided by 3b over 1. What do you do when you are dividing?
Question.
You leave the first one alone, turn the second one upside down, and multiply it. A over 15b. Same idea there. Put that over 1. Is this 3 over t divided by?
Sarah thinks I'm like channeling friends. I'll slash your hands off.
So 3 times 1 is 3, and that times that. Nothing can cancel, so that's good.
I can't hear it. I just hear a movie noise right now. I'm not kidding.
This is the same idea. It's this divided by this. Turn that one upside down, multiply. Factor, 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 cancel.
Yeah, I'm gonna hang myself right here.
Oh, whoa, man.
I'm actually gonna do some stuff right
So maybe you're angry.
here. I'm gonna go for a bit home.
Homework.
I don't know if I want to just I don't know if I want to abandon my course in like just
It's up in the office, and I didn't go get it.
what?
Can we get next class? Stay in school.
I
have that on video. Because I don't know, because I was recording
Oh, stuff.
I'm happy with my grades. I used to think that
See you Wednesday.
See you Wednesday.
I went on the honor roll for the whole fall semester so far.